Newton's first law of motion states that an object at rest will stay at rest and an object in motion will stay in motion until an unbalanced force acts upon it. The skateboard and plush are at rest at the top of a slope. The force of a human hand pushes the board. The skateboard rolls down the slope. The skateboard hits an unbalanced force of a wooden block, which stops the board. However, because of the plush's tendency to stay in motion, or its inertia, and the fact that it is unattached to the skateboard, the plush flies forward off the board. This demonstrates Newton's first law of motion because it shows the tendency for an object like the plush to stay at rest, or, in this case, in motion.
According to Newton's second law, acceleration is produced when a force acts on a mass. The greater the mass, the greater the amount of force needed to accelerate the object. In this example of Newton's second law of motion, Julian uses force to pull the light blanket, causing acceleration. In this example of Newton's second law of motion, Julian pulled the blanket with Julian's brother on it, making the blanket heavier. Julian used more force to pull the blanket, but since the blanket had more mass, it caused less acceleration. The two examples show that the more mass with the same force causes less acceleration.
Newton's third law states that for every action, there's an equal and opposite reaction. Here I am pushing on a wall. First, I have my hand ready to press against the wall using potential energy. Now I have my hand on the wall, which is creating an equal force on my hand, and my hand is creating equal force on the wall.